let's talk about fluid biophysics. Density.
What is density? Density is how tightly packed a mass is in a certain amount of space. As we can see here, the more mass occupied a space, the more dense the substance is, whereas the less mass occupied the substance, so the less dense the substance is. The density can be measured by the rho equal to mass over volume, and the SI unit for the density is kilogram per meter cube. As we all know, the density of water equal to 1 gram per cm cube. Now we move on to the relative density. Relative density is also known as specific gravity. The relative density is defined as the ratio of the density of the substance to the density of water. So mathematically, we can also define the specific gravity as the density over 1 gram per cm cube, when the substance with the specific gravity less than 1, so it will float on the water. So this simply means that it is less dense than water. Thank you.
Assalamualaikum. Next, I will explain on the pressure. So today I will focus on the two principles, which are Pascal's and Archimedes. First, we will focus on the Pascal's principle. Pascal's principle stated that a change in the pressure at any point in an enclosed fluid at rest is transmitted undiminished to all points in the fluid. So in this diagram, we just apply a small force on the piston 1, then we can lift the load at the piston 2. So the formula is F1 over A1 equal to F2 over A2. Next, we move to the last principle, which is Archimedes' principle. Archimedes' principle stated that the buoyant force applied by the fluid is equal to the weight of the displaced fluid. So this diagram shows that the load with 5 kg, which is displaced in the water. As we can see, there are 2 kg of buoyant force is applied on the 5 kg of fluid. So 2 kg of water is displaced. So as we can see, 2 kg of water is equal to the 2 kg of buoyant force. So this proves that the Archimedes principle.
Okay, hi. I will talk about surface tension. Okay, first, let's define surface tension. Surface tension is the tendency for water molecule to cling to each other due to hydrogen bonding between molecule and to form water droplet. In our daily life, surface tension can act like a thin layer of solid surface that allow flotation of object on the surface of the water strider walking on the surface of the water, and separation of oil and water. And surface tension can be defined mathematically as this formula, which is gamma equal to force over parameter length. Force can be expressed as the unit of Newton, while parameter can be expressed as the unit of meter. And we can calculate the pressure due to surface tension as P equal to 2T over R, whereas P is the pressure, T is the surface tension, and R is the radius. Now let's move on to the surfactant. As we all know, surfactant is a substance that reduces the surface tension, such as example is the detergent. Okay, in our daily life, there is surfactant that act physiologically on our body to help we breathe normally. The surfactant exists in our alveolus. The surfactant in the alveolus allow the alveolus to expand and contract during inhalation and exhalation. As we inhale, the alveolus expand to increase its surface area, allowing exchange of gases, and contract when we exhale. Okay, I'm done here. That's all. Thank you.
about viscosity. Viscosity is the measure of fluid's resistance to flow. Viscosity depends on concentration of solute, temperature, and pressure. If the concentration of solute increase, the viscosity will increase. If the temperature increase, the viscosity of liquid will decrease and viscosity of gas increase. If the pressure increase, the viscosity will increase. Viscosity and density have correlated. If density increase, the viscosity will increase, which make the substance ability to flow is less. Next, the formula for viscosity is force divided by area per with length divided with velocity. The unit for viscosity is PAS, which is the Pascal second. Under viscosity, we have Poiseuille's law. Poiseuille's law is the velocity of steady flow of fluid through a narrow tube varies directly as a pressure and the fourth power of radius of the tube. This is the formula for Poiseuille's law. Q equal to delta P pi R4 divided by 8 viscosity air. The unit for Poiseuille's law is Pascal. Next, under viscosity, which we have fluids and blood flow. Fluids, we have two types of fluids, which is the Newtonian fluid and non-Newtonian fluid. Newtonian fluid is the dynamic viscosity constant at different velocity, directly proportional between friction force inside the fluid and flow velocity, for example like water. Next is the non-Newtonian fluid. Non-Newtonian fluid is the dynamic viscosity changes with velocity, for example like blood. To measure the fluid's viscosity, we use volume, flow, or rate, which is Q equal to V over T. Next, we move to the blood flow. We have two types of blood flow, which is the laminar flow and turbulence flow. Laminar flow means that the fluids flow in orderly, but turbulent flow, the fluid move in disorderly flow with vortices and eddies. To determine whether the fluid is laminar flow or turbulent flow, we use Reynolds number. For the equation for Reynolds number is Re equal to V times by D times by P divided by viscosity. And thank you, that's all from me. Thank you for watching.